Okay, introduction of LED. LED is a light emitting diode, or LED for short. It's a type of light source that is not to be confused with a luminaire or light fixture. A part of the entire fixture is an LED. Sign an LED use solid state technologies akin to the memory in your computer. It is also known as solid state lighting (SSL). The term light emitting diode or LED refer to a semiconductor that emits light with a specific wavelength or color. When an LED is turned on, the electron and hole can join again, releasing energy in the form of photon. This is referred to as the electroluminescence effect. Okay, typical effectiveness is used to describe the energy efficiency of LED goods. In simple terms, efficiency is the ratio of power input to light output. No more precisely, emitted flux lumens divided by power draw watts. When compared to other luminaire, the LED efficiency of an integrated LED light or an LED luminance is different. The total efficiency of the system is decreased by real lighting fixture. Significant elements such as control gear performance, degradation of the luminous flux with rising junction temperatures, and optical loss. In contrast, the efficiency of LEDs is increasing quickly and can endure for many years at more than 2000 lumens.
Hi, my name is Ahmad Ashraf bin Muhammad Ali, and I will present to you the origin of LED. The history of LED starts when Henry Joseph Round, a British radio researcher and Guglielmo Marconi's assistant, made the discovery of electroluminescence, or the generation of light-emitting phosphorus, in 1907. Electroluminescence was first observed in silicon carbide. Round reported that the yellow light was produced when a current passed through a silicon carbide detector. The history continued when World War II George Destriau noted that electroluminescence could be produced from, this time, zinc sulfide powder after applying an electrical current to it, producing light. Hefty research was done on phosphorus in connection with work of the radar display. Even though no practical LED was created, his research did influence and help future inventors in inventing LED. In 1921, a Russian scientist named Oleg Vladimirovich Losev was continuing research on this topic. With the support of George Destriau in 1935, they continued to investigate the conductivity of metal alloy. A copper particle has contaminated with the zinc sulfide that was used by the Destriau, which caused light emission when the voltage is applied. This phenomenon was later named laser light. Due to his finding, he developed electroluminescent film that was mainly used on aircraft cockpit. This was the first practical application of the luminescent effect of inorganic substance, which called the Destriau effect. A man named Nick Holonyak, a professional engineer for General Electric, created the first LED in 1962 after Robert N. Hall, his colleague, had created a laser that utilized a semiconductor diode, only infrared radiation, which is invisible to the human eyes, was produced by Hall's laser. The idea to create a diode technology that will emit visible light was inspired by this occurrence. In 1962, Holonyak was successful in operating the first functional visible LED device using the semiconductor material, gallium arsenide phosphide, and the stimulate emission method. The instrument of Holonyak flashed a red light. After creating the first LED successfully, he expanded the color assortment to include blue light and green. Upon the accomplishment, white LED were created, which led to the revolution in the lighting business in 1962.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazman bin Saleh, and I will be talking on how does an LED operate. So LED operates on electroluminescence concept, which is a concept where electrons and electron holes recombine in a semiconductor, producing lights in different forms such as infrared, visible, or UV. Different light color depends on different light wavelengths, which depends on the energy band of the semiconductors used. An LED has many features, some of which are LED lights are neither highly monochromatic nor spectrally coherent. LED lights only appears as saturated colors as its spectrum is sufficiently narrow. The radiation emitted is not spatially coherent, different compared to lasers. Next, we will be talking about OLED, which is organic light emitting diode. What is the difference between OLED and LED? OLED contains an organic material that composes the emissive layer of the diode. These organic materials may appear in small organic molecules in a crystalline or polymer phase. What is so good about OLED compared to LED? OLED has various advantages such as thin, low-cost displays that uses low driving voltage, wider viewing angle, high color gamut, and contrast. How does organic material conduct electricity in OLED? The organic material becomes electrically conductive due to the delocalization of pi electrons caused by conjugation over most molecules. What is OLED used in? It is used to make displays for mobile electronic devices such as digital camera and smartphones. So, how is an LED powered? When a voltage is applied, the current in an LED or other diodes rises exponentially, causing a large change in current event even when a small change of voltage is applied. This causes the current in the LED to be regulated by an external circuit such as a constant current source to prevent damages to the diode. The power converter is included into LED fixtures or a current limiting resistor. There are some examples where the internal resistance of small batteries were sufficient to supply current within the LED's rating. Next, we will be moving on to electrical polarity. What does it have to do with an LED? LED will only turn on when a voltage is applied in a forward direction of the diode. If the voltage is applied in a reverse direction with a sufficient limit to avoid damage, it will become a useful noise diode. If voltage is applied in a reverse direction, no light will be emitted and there will be no current flow. Energy band of any diode is higher in reverse bias compared to forward bias. Since the wavelength of the light is determined by the energy band gap, the color emitted won't be the same when reverse biased. If the reverse breakdown voltage is sufficiently high, the emitted wavelength won't be similar to visible light. Any single LED can emit visible light when reverse biased, even in dual LED packages. Lastly, I will be talking on how does an LED emit colored light. Single color LEDs can emit light in the narrow wavelength band from near infrared through the visible spectrum and into the UV range thanks to the use of different semiconductor materials. The operating voltage of LEDs can be increased by shortening the wavelengths. For example, the color white can be produced by mixing the three primary colors which are red, green, and blue, but it can also be produced in many other ways. Next is blue or UV. The method used referred to as cladding layers, which blue LEDs have an active region that consists of one or more ingot quantum wells that are sandwiched between thicker layers of GaN. So that is all from me. Thank you.
When compared to LCD, adopting LED technology offers various advantages or benefits, such as good image quality. LED displays feature a range of backlight combinations, but they also frequently provide better picture quality. Additionally, some lighting configurations produce images that are superior to others. Greater impact will be achieved by using lighting effects. Additionally, it uses less energy. A LED contains a semiconductor. A consequence of electrical energy crossing the semiconductor junction is the production of light. As a result, light is generated without the requirement to first activate a different light source or light-producing load. LEDs are therefore more energy efficient than rival alternatives. The device is then programmable after that. They are programmable to change color in response to different radio inputs. For instance, you might configure the LEDs to change from green to red, depending on whether the gadget is armed or not. Alternately, you can fade from one color to another depending on how much throttle is applied. Residential lighting in color. As an illustration, the use of color has changed from being regarded as an oddity to an exciting component of home design. Color is controlled in this house using a DMX interface and workstation controlled to trigger pre-programmed effects. Programming is controlled via wall controls or a PC connection to the control system panel. With LEDs, we can do that to change the color of the lighting inside of structures. Other than that, LED lighting leads in a reduction in energy use overall when placed in freezer cases. Significant energy savings may result from advancement in LED directionality. Better optical control, reduce light loss from operating fluorescent bulbs and low temperatures, and reduce heat. Other than that, they live a very long time. They don't have any moving parts that can eventually burn out or break, which is why this occurs. Additionally, there are no filaments, oxidation, metal fatigue, or electrical component evaporation. A standard LED light is a rather robust piece of equipment. They are reliable devices without moving parts, glass that could break, or glass that could shatter. This suggests that they will last far longer than regular light bulbs. Those who are technically oriented say that the way they emit light is a crucial aspect of their lifespan, because they are constructed of substrate semiconductor materials and feature two portions of P positive and N negative dope zones. Last but not least, they are environmentally friendly as LED lights convert 95% of the energy they consume into light, only losing 5% of it as heat. Because of this, LEDs consume less energy than traditional lighting sources, which is better for the environment.
Alright, moving on to the disadvantage of LED. Indeed, LED is very convenient and very much more powerful in terms of lifespan. But however, LED is more expensive than conventional light bulbs. This is because due to its high manufacturing cost than light bulbs. Alright, the next disadvantage of LED is high temperature sensitivity. This is because LED requires a very significant sensitivity of temperature. This is because a higher temperature may damage the circuit and other components of LED. Alright, and the next disadvantage of LED is LED bulbs usually emit a cooler blue tinted light in contrast to conventional light bulb. And lastly, the last disadvantages of LED is LED has an integrated built-in design. So in the case of using wall LED lighting fixture, in case of complications and some kind of damage happens within the fixture, you need to replace the whole lighting fixture of the LED. This will resulting on a higher cost to replace the whole fixture.
Researchers right now are studying to get a better understanding on how we can diversify the use of LED in our daily life. LEDs are perfect for many industrial uses because of their high efficiency and directed nature. Refrigerated case illumination, parking garage lighting, walkway and other outdoor area lighting, modular lighting, and task lighting are all using LEDs more and more frequently. Such as recently, a study for developing an LED preservation technology to minimize strawberry quality deterioration during distribution. This study examined the impact of LED illumination on characterized and Botrytis cinerea and Rhizopus stolonifer inactivation. It concludes that 405 nanometer LED technology reduced fruit supply chain post-harvest deterioration. That's all from me. Thank you.